From that point in this chapter, he also, which I think is also very important here, he makes a distinction between theory and between science and pseudosciences. And what he's doing is he's anticipating, because his argument, as much science is based upon and predicated upon evolutionary theory, he's already anticipating those folks who are going to read this and say, well, I don't buy evolutionary theory. It's just a theory like any other theory. And so what he does is to make clear that when we talk about scientific theory, we mean something different than we just talk about theory in a kind of garden variety way. And that scientific theory actually goes through an acid wash of testing. And that it's meant, if it can be proven wrong or invalid, it's meant to do that, and preferably to do that at the beginning so that you're not wasting your time. Good science or pure science is, he would argue, ultimately objective. That it's not governed, as he would say, a postmodernist would argue, it's not governed by, say, political bias. It's not governed by cultural bias or by economics, but that is absolutely objective. And so when he makes that distinction between what we mean by science and counterfeit science, he lays out the different criteria for that, for it to count as real science. And you recall, there has to be a sense of repeatability, that what you discover has to be able to be repeated in different conditions, in different kinds of lab. There has to be a sense of measurability, that you can measure your results. There has to be the idea that it can lead to heuristics, a discovery of other kinds of ideas that will then confirm the original theory. And so he says that science meets all of these criteria. The pseudosciences or the false sciences don't, and he includes in that creation science and ufology and so on. So what he's doing there, again, is not only showing us the characteristics of science, but also rhetorically, he's anticipating those who want to reject his argument because their belief is one that would reject evolutionary theory in favor, for example, of intelligent design or what am I thinking of? What's the word, please? Creationism, that's right. And in fact, he would, if somebody asked, well, why, we talked a little bit about this in my class, should, part of the debates that have been taking place in Kansas over the past few years, and not just Kansas, but other states as well, whether evolution should be taught in the high schools or whether creation science, or creationism, intelligent design, should be taught in the high schools. And he offers a pretty clear response to that from the point of view of a scientist. He would say that it should not, creation science, intelligent design should not be taught as a science because it doesn't meet these criteria, therefore it's not a science. He wouldn't say that it shouldn't be taught in school, but it shouldn't be taught in science class. And in fact, he was here a couple of years ago and met in this room with CTI 100 students. And that question came up, and he said something which I think is very helpful in understanding his point of view. He said what intelligent design is essentially, and this is why it's not scientific, it's not even quite logical. He said it's essentially a throwing up of the hands followed by a non sequitur. And non sequitur means literally does not follow. Logically, it doesn't follow necessarily. The throwing up of the hands is this, that intelligent design rests upon the notion that organisms and cells are so complex that we can't understand them. That's the throwing up of the hands part, that we can't understand them. You say we can't understand them really yet, but we can't understand them. So that's the throwing up of the hands. The non sequitur is saying, therefore, God must have created them. And that's what doesn't logically follow. Right? You can say this is so complex that we can't understand it yet. It doesn't logically follow that. Therefore, God created them. So it doesn't qualify as science, and that's what he's trying to do in this section, to head off those arguments. He follows this then with a description of what a working scientist has to do. And again, what he seems to go back to is this notion of work and discipline, and the idea of experimentation, and the willingness to make mistakes, and desire really to make mistakes and find those out earlier, so that you can get on the right track. In some ways, I suppose you might liken it to Mill's rhetorical strategy. One of the reasons that Mill, as he works through his own arguments, you recall, and sets up oppositional arguments, is because, and it sets up valid oppositional arguments, not just sort of straw figures that you can knock down very easily. The reason that he does that is that Mill is less interested in just appearing to be right than he is in finding the truth. And so he wants to find those oppositional arguments that might reveal the weaknesses in his own argument, so that if he has to change his argument, he can. And in the same way scientific methodology works through the confrontation of evidence that might contradict it, it wants to pursue that, because Wilson would argue pure science is less interested in appearing to be right than in being right and finding out what the facts are, even if that means changing what you thought you knew. He ends by talking about this attempt to return to the ideas of the Enlightenment and the consolidation of knowledge through logical positivism. He says that it ultimately failed, though, because of semantic difference, that they couldn't agree on the difference between fact and theory and so on. And he says really the problem is that they didn't understand the brain sciences very well, and that if we do, and here he's setting us up for where he's going, that if we really understand neurophysiology, if we really understand the brain, then we can start to understand much more clearly and accurately why we do the things that we do, and why we behave in the way that we do, and consequently we can establish wiser and more enduring ethical precepts and laws. Then we move on to chapter 7, Genes to Culture. And I like this chapter. I think it's a fascinating chapter. It's a complex chapter, and it's very difficult always to move through it in the time that we have available for it. Essentially, his argument here is that he's trying to reconcile that split between nature and nurture, the old arguments between science and the humanities. Nurturists would argue that we are who we are, that we behave in the way that we behave because of our environment, because of our circumstances. This is certainly what Mill, the tradition out of which Mill came, that we're constructed by our culture, by our society. The other side of that argument, those who would argue on the side of nature, would say that we are who we are because of genetics, that we are genetically predisposed to behave in certain kinds of ways, and so do behave in those kinds of ways. And what he's going to tell us is that it's a false split. It's a false dichotomy. That in fact they're inextricably linked. That biology informs culture, and culture informs biology, and that they work upon each other in this way.